So in this video, I want to explain how to prepare rigid solvent gels using agar as a gelling material and progressively replace the water in the hydrogel by organic solvents that are going to be useful to dissolve the old adhesive. So in order to prepare solvent gels, I'm going to weigh 2 grams of agar powder and use that powder with 30 milliliters of water, cook it in the microwave, and then I'll add 10 milliliters of ethanol. This way we'll have 2 grams of powder in 40 milliliters of liquid, and that's a 5% gel. So I use a pocket balance, which is precise enough for most things that we need to weigh in conservation. And I just put in 2 grams. There we go. I prepared a beaker and I'm going to use the little tray to pour the powder in. And I prepared as well 30 milliliters of demineralized water that I'm just pouring in. So now I'm going to microwave the agar gel. So it's agar and 30 milliliters of water in the microwave. I put it on to 700 watts and I leave it for about 15 seconds or so. And the idea is that I actually wash it. It's like instant oatmeal in a microwave. You don't want it to pour over and make a mess. So I leave it about 15 seconds and then I give it a little stir. Put it back in. And now I really have to watch it because I'm actually going to stop it when I see it's boiling. So of course the exact cooking time depends both on your microwave and on the amount of solution you have. The more solution, the longer the cooking time. And if you were to have a slightly less powerful microwave, you certainly will have to extend the time a bit. So now I just come back from cooking the agar in the microwave. So that's again 2 grams with 30 milliliters of water. It's now nice and liquid and warm. And I have here prepared 10 milliliters of ethanol that I'm going to pour in the agar. So now we have the warm agar with 30 milliliters of water. And I'm going to pour the 10 milliliters of ethanol in there and quickly stir, because otherwise it's going to become cloudy. And then I use a petri dish that I prepared to pour the gel. Cover it because there's ethanol. We don't want that to evaporate too quickly. And as it cools down, the gel is going to become rigid. Right now it's liquid. It's going to become rigid within 20 minutes or so. I want to explain how to make agar PVA borax gel. So it's a modified version of the agar gel with the addition of PVA borax. PVA and borax both come in the shape of a white powder. This is borax and this is PVA. And they get dissolved into flasks of water, demineralized water. We're still going to use agar as the main gelling material, and we're going to mix everything with water, microwave it, and then again add the solvent to make solvent gels. Earlier, I prepared 5 grams of PVA that I'm going to pour in 50 milliliters of water. in order to obtain a 10% PVA solution in water. It's going to take a while to get dissolved, so we're going to have to be patient. It's going to get dispersed and dissolved little by little. Now I'll pour 3 grams of powder borax in 50 milliliters of water, and that's going to be a 6% solution. So with the borax solution, we can increase the rate of dissolution of the salt by increasing the temperature. So this is a beaker with hot tap water that I prepared, and I just put the borax solution in it, and it's going to help with the dissolution. The PVA, though, will take quite a few hours before it's dispersed. So in order to prepare, in order to avoid waiting time when you're in the lab, it's better to prepare it the day before. So now we're going to prepare Agar PVA borax gel. The main ingredient is going to be, like earlier, for the pure agar gel, the agar powder. And then we're going to add PVA and borax. Both solutions were prepared earlier, so they're already nice and smooth and diluted. And the idea is to have the agar in a beaker. Add some water. So we have 1.4 grams of agar, 23 milliliters of pure water, and we're gonna add 6 milliliters of a 10% PVA solution. So that's, I've got a pipette with 2 ml, so I'm gonna put 3 times 2, that's 6 ml. That's the PVA. And then I'm gonna add the borax, and here I'm adding 0.6 milliliters. And now I'll take this solution to the microwave to cook it. So I've microwaved the agar with the PVA and the borax. That's a solution that's warm now. And I'm going to pour in it 10 milliliters of ethanol and stir. The solution gets a little cloudy, but by stirring it, it's going to get smooth and homogeneous again. After a few seconds of stirring, it's now ready to put in the petri dish and to cast. There we go. So now we have the agar gel that's been prepared with water and ethanol, 70% water, 75% water, 25% ethanol. And what I'm going to do is to cut slabs of gels, and I'm using my notebook with the lines to cut evenly and cut straight lines. And what we're going to do now is to soak the gels in successive jars containing different concentration of ethanol. We're going to go from 50-50 to 75% ethanol, 25% water, to 100% ethanol. And finally, the last jar contains pure methylethyl ketone. It could also be ethyl acetate, for instance, any solvent that you want to use to actually remove adhesive from paper. So what I do now is to take the slabs of gels from the first jar, where it stays for 2 hours, to the second one, where it's going to stay as well for 2 hours. And so 2 hours in each jar, and at the end we'll have a gel soaked with methylethyl ketone, which is a very useful solvent for tape removal. So for the application of solvent gels on paper, we have this paper sample which has stains from old pressure-sensitive tape adhesive that we're going to try to remove using both solvent gels, the Agar PVAB and the pure Agar, that have been soaked into a successive bath of solvents and ultimately in methylethyl ketone. We're going to apply those either directly onto the paper, or we'll use a pre-treatment of cyclomethicone. That pre-treatment aims at reducing the risk of creating stains during the application of the gels. So for the direct application of gels, I'm going to pull out a slab of each gel and apply it directly onto the paper sample we're treating. And I'm using filter paper to remove the excess solvent from the gel. So this is the Agar PVAB, and this is the pure Agar. So it's an important step because we don't want excess solvent to actually create unwanted stains in the paper. I'm going to apply one here and one there. And cover them up with a piece of Melnex to lessen the evaporation. Now what I can do is put on top just a tiny little bit of weight. So these are Ziploc bags with methyl cellulose, and they just bring a little bit of weight. And one thing that you can do with those Ziploc bags with methyl cellulose is pop them in the microwave for about 5 seconds to get them a little bit warm. And a little bit of warmth will help to speed up the dissolution of the adhesive that we want to remove from the paper. So I'm going to put my timer for 20 minutes, and in 20 minutes we'll see the results. So for the second application demonstration, I'm going to use cyclomethicone, which is a silicone solvent that I apply quite liberally on the area to treat. I could apply it from the back. I can also apply it around and on top, and then dab it off a little. It creates the appearance of oil stain on the paper. However, it will completely dissipate in a matter of a couple of hours. I dab it a little bit as well. There we go. And then the two gels, exactly like I did earlier. Let's do that. And the second one will be the Agar one. So that was Agar PVAB in methylethyl ketone, and the second one is pure Agar in methylethyl ketone. I use again the Ziploc bags with methyl cellulose to apply a tiny bit of weight and set my timer for 20 minutes for those as well. So after 20 minutes, we've removed the gels that were used for direct application onto the paper, and now I'm removing the gels that have been applied with the pretreatment of cyclomethicone. So this is the Agar PVA, and this is the pure Agar. So we can see that, obviously some discoloration, some discolored adhesive has transferred to the gel. And once the cyclomethicone has evaporated, we'll see the efficient how efficient that pretreatment is to prevent the staining of paper. Now it's been a couple of hours, and the cyclomethicone that had been applied previously has now completely vanished, and we can look closely at the paper sample. The two samples on the left were pretreated with cyclomethicone, while the two samples on the right had a direct application. Obviously, on the right we have a stain that has been created through the direct application. Cyclomethicone, used as a pretreatment, actually prevented quite efficiently that stain. If I flip the piece of paper to look at the back, the verso, it's also obvious that here we have the stain and here we don't. However, the difference between Agar and PVAB gel, Agar PVA borax gel, and pure Agar gel is not obvious for either the direct application or the application over the pretreatment using cyclomethicone. In conclusion, it is possible to make solvent gels in the conservation studio using Agar either pure or Agar mixed with PVA borax. It's also a very versatile solution because ultimately we can load the gels with either methylethyl ketone or with, for instance, ethyl acetate. We could also use another solvent if we wanted to. Importantly though, I want to insist on the fact that using ethanol as a co-solvent is really important. Ethanol is miscible both with water, which is necessary to make the gel initially, and it's also miscible with most organic solvents that are going to be used to remove the glue from the paper. So without ethanol, there won't be ingress of solvent in the gel. The ethanol actually helps the gel, which acts like a sponge, to soak up the solvent that we're going to use to remove the adhesive from the paper. So when treating a paper object with solvent gels, you still have to decide on the parameters of application of your solvent gels. For instance, how long are you going to leave them on the paper? Are you going to raise slightly the temperature or do the treatment at room temperature? And lastly, are you going to use the pretreatment cyclomethicone or are you going to apply the gels directly? All of those decisions are the conservator's decisions based on the artifact that you have and the type of adhesive stain that you have. Thank you.